Bismillah salatu wassalamu ala Rasulullah sallallahu alaihi wasallam. Assalamu alaikum wa rahmatullahi wa barakatuhu. Our today's topic is VLSM, that is called variable length subnet mask. And this variable length subnet mask strategy is used by the network engineers to calculate the subnet mask for each and every segment in the network. Okay, if we are looking at the diagram, that is a topology diagram. Okay, in this topology diagram you can see that we have three different networks are here. Okay, we have three different networks are here. One network is this one, that is from router to router and has two hosts. Okay, and this is another network that is connected with router 0, and here the requirement is 25 hosts, and one network that is connected with router 1 that is having 45 hosts. Okay, so what we will do, we will calculate the subnet mask according to the requirement of the network. Okay, for that purpose what we will do, we will use the VLSM technique. Okay, in this VLSM what we are doing, we are taking taking the requirement, okay, as it is given here. So we are saying that we are starting from the largest network. So for the largest network our requirement is 45 hosts. Okay, this is our first requirement. The second requirement is 25 hosts, and the third requirement is we have 2 hosts. So these are three requirements that we have in our network topology. Now what we will do, as we know that the formula for calculating the host, is this one, 2 power h minus 2. This is the formula for the calculation of hosts in any network. Okay, so we will put the values here in this formula and we will compare it with the requirement, that is our first requirement, 45 hosts. We will put the values here in the formula until we will get this value or greater than this value. So we can say that 2 power h minus 2 must be greater than or equal to our requirement, and in this case our requirement is 45. Okay, so we will put the value here in this formula, 2 power h. The first value we are putting here, 2 power 2 minus 2, that gives us 2, and 2 is less than 45. Then we will put the value 3, 2 power 3 minus 2, that will gives us 6. 2 power 4 minus 2 gives us 14. Okay, 2 power 5 minus 2, that gives us 30. 2 power 6 minus 2, that will gives us 62, and this 30 is less than 45 and 62 is greater than 45. So we can say that our value of h is equal to 6. Okay, and the given network here in this networks, for these network segments, the given network is 192.168.1.0/24. Okay, so our first network is 0. So h is 0 here, h is 6 that we have calculated here. Now we will, with the help of this h, we will calculate the value of s. As we know that this is class, which class is this? Class C, and class C has default subnet mask /24. Okay, what does mean /24? /24 means that our network bits are 24 and host bits are how many host bits are there? 8. We have total number of host bits 8 here in class C. So the h bits are, or the host bits are 6. Then what will be the s bits? 8 minus 6. Then you will get the number that is s. Okay, s are the bits that we have taken from the host portion for subnetting. So s is equal to 2. It means that we have taken 2 bits out of 8 bits. The total number of bits are 8. 1, 2. These two are 2 bits. S is equal to 2, and host bits are 6. We have calculated 1, 2, 3, 4, 5 and 6. So these are the bits now in host portion, and these bits are called S bits. Those are converted into ones. Okay, initially these all bits were 0, but when we are doing subnetting, then this is 2 now. Okay, we have taken 2 bits from the host portion, so S is equal to 2. What does these 2 bits will gives us one more thing, that is called subnet mask. Subnet mask 2 means the first bit value is 128, the second bit value is 64, and also there is a table for this purpose, that if you will memorize that table, then you will directly get the values. If you are having 1 bit, what will be the value? If you have 2 bits, then what will be the value? 3 bits, what will be the value? Okay, or the other way is you will add these numbers with each other, that will gives us 192 here. Okay, so the subnet mask is 192. Okay, with the help of H we got S, with the help of S we got subnet mask. Now with the help of subnet mask we will calculate what is block size or magic number. Block size or magic number, both names are for the same purpose. So the block size value is, we have a formula for calculating the block size, 256 minus subnet mask, and we have calculated the subnet mask here 192. So 256 minus 192, that will be equal to, if we are subtracting from here 256 minus 192, then we will get the value 64. Okay, so our block size value is 64. The question is why we are using, or why we have calculated this block size value. We have calculated this block size value to calculate the number of subnets, to calculate the number of valid subnets. Okay, so the first subnet will always be the given number, the given network address. Okay, so in this case, if here it is /24, so the given network is 1.0, so the 0 is the first subnet, and the second subnet we have calculated from here, that will be 64. Block size is added with the first network, that will be the second network. If the first network is 0, then you will add the block size value with 0, you will get the next network. Similarly, if you have the block size other than this 64, then you will add that value with that number. Okay, so for the first network, that is 45, so we are saying that our first network is 0, yani the first network is 192.168.1.0 and /2 bits we have taken. The default bits are 24 plus 2, 24 plus 2 gives you 26, so the subnet mask is 26, or in dotted decimal notation it is 192. Okay, so this is the subnet mask for the first network. Our next requirement is 25 hosts. So we will follow the same steps that we have taken for this for 45 host value. We will follow the same steps. Okay, so we will put the value in 2 power h minus 2. Now our requirement is, instead of 45, our requirement is 25. Okay, so we will put the value one by one. 2 power 2 gives us 2 is less than 25, 6 is less than 25, 14 is less than 25, but 30 is greater than 25. So our required value is 5. So h is equal to, in this case, h is equal to 5. If h is equal to 5, what will be s? S is equal to 8 minus 5, that is equal to 3. If s is equal to 3, then with the help of this we will calculate the subnet mask. Okay, 3 bits are there. Now we have 1, 2 and 3 bits are s bits, and these 5 bits are the host bits. So 128, or if you know the table, that the value of in the table is 224, and if you don't know the table, then you will add 128 plus 64 plus 32 here. Okay, and that will gives you what? 224. So the subnet mask is 224. Now subnet mask is 224, then what will be the block size or magic number? 256 minus 224. 256 minus 224, that is equal to 32. Okay, so block size value is 32. Our next network we have already calculated, that is 64. So the next network for 25 host is 192.168.1.64, and the subnet mask we have calculated right now 224 with S is equal to 3. 24 plus 3, that will gives you 27/27. Okay, and what will be the next network now? Because we have also third network that is having 2 hosts. The next network, you will add this number with the next network, that is 64. You will add 32 with 64, and then you will get the next number, that will be 96. Okay, 4 plus 2 6, and 6 plus 3 96. So this network value is 192.168. this network value is 192.168.1.96, but we don't know what is the subnet mask. Subnet mask we have to calculate by following the same steps. Okay, we have 2 hosts, so our requirement is fulfilled here. So H is equal to 2. If H is equal to 2, okay, if H is equal to 2, then what will be S? S is equal to 8 minus 2, and then 8 minus 2 is 6. So S is 6. Okay, if S is 6, then what will be the subnet mask? What will be the subnet mask? We have 6 bits here, 1 2 3 4 5 6, and these 2 bits are 0. If you will add these numbers, or if you know the table, then you will get the value 200. Subnet mask will be 252. That will be your subnet mask. Okay, so you got the subnet mask for this network. Clear? So this network subnet mask is 252, or 24 plus 6, that is equal to 30. That is equal to 30. Okay, clear? Now next network will be, what is the block size value? Sorry, I didn't calculate the block size value. 256 minus 252, that will gives you 4. So the next network will be 96 plus this number will be added with 96, and you will get the next network value 100. Okay, so by this way you will calculate the subnet mask with VLSM. Okay, one more thing that you have to do is, that is the broadcast address. Broadcast address. Now the broadcast address will be just before this next network. And you can say that if you are subtracting 1 from here, you will get the subnet mask for the previous network. Okay, so 64 minus 1, that is 63 is the subnet mask, and 96 minus 1, 95 is the broadcast, sorry, not subnet mask. 63 is the broadcast address for this network, 95 for this network, and 99 for this network. So we have only 3 networks. No need to calculate the broadcast for this network, but because we don't know what will be the subnet mask for this network. Okay, we have calculated just 3 networks here. Okay, so these are 3 networks, and these are the broadcast for these 3 networks. And what are the valid addresses that we can configure on our computers or our machines? So in between the network address, this is the network address, and this is the broadcast address. In between the network address and broadcast address, you have all valid addresses that you can configure here, or on these PCs. Those are in these networks. Okay, so for the first network from 1 to 62, second network 65 to before 95, 94, and these are only 2 IP addresses, 2 host addresses. Those are 97 and 98, and the 99 is your broadcast. Understand? I hope it will be helpful for you people to understand the VLSM. Thank you very much. Take care of yourself. See you inshallah in the next lecture.